Hello everyone, welcome back to Diksha Karnataka YouTube channel, and you are watching PU2 Brahmastra series, and we have already completed chapter wise most important questions. So today I am going to discuss most expected derivations. So here I am going to discuss some of the derivations that I have already discussed, some of the derivations I have skipped while doing the chapter wise derivation. So if you watch this video, you will be good to go for all the derivations, all the 5 marks derivation questions. You can answer them quickly, and this will be one stop video for all the important derivations. Now remember that there are some other questions in long answer type questions other than derivations. For example, if you have watched my wave optics chapter, in the wave optics chapter there was 1 or 2 questions which are not a derivation, just 1 mark, 2 mark type questions. So they are called split type questions. In fact, the similar type of questions also come in from the chapter dual nature of radiation and matter. Also we have a 5 mark question from the chapter semiconductor, right? Full wave rectifier, half wave rectifier. They are not derivations, so that's why I am not going to discuss them in this lecture. This lecture only we are going to discuss those which require some kind of mathematical analysis, some kind of mathematics involved, and most of the students struggle to answer those questions. That's why I will only discuss the derivation questions, not the full long answer type 5 mark question. If you want all the long answer type 5 mark question, you can check the chapter wise videos. There is a link given in the description where you will find all the Brahmastra series videos. Chapter wise discussion is done for all the subjects, so don't go anywhere. You can check all the videos there, but here at one stop derivations. Okay, so all the mathematical calculation related problems we will be solving here. Okay, in the next class, that is on Friday, we will discuss some important numericals. So I know many students struggle in numericals as well. Not many, most of you actually struggle in numerical questions, so we will be taking care of that as well. So if you watch that video, all the numerical questions related, what type of questions you can expect, and that will not be super long video. We will suggest only few numerical questions from very suggestive chapters, so that will not be entire chapter wise. All the chapters we will not going to cover, because that these are considered for the weaker section of the students. If you want all the chapter wise discussion, that is already done in the previous 14 videos that I have done from the physics Brahmastra series, so you can check them out. Right now, as you know that we are currently going through one of the most important series, PU2 derivation. So PU2 Brahmastra series, this is almost coming to an end. We have almost completed all the chapters. Today I am going to discuss about derivations, and Friday, as I said, will be numericals. You can check other subjects what are all going to happen in this week. Mathematics is already completed. What we are going to do in the biology, chemistry, and chemistry again, what all we are going to discuss throughout this week, and we will be concluding this Brahmastra series. So all the PU board aspirants who are struggling to score well in your PU board, they can follow this entire series. It is everything at one place. Right now, let's start with this thing, that PU2 success blueprint test series, which we have launched and it is currently ongoing. We have already completed 4 part test in this series, and right now we will be doing 8 full length syllabus full length tests. So there will be 2 physics, 2 chemistry, 2 maths, and 2 biology. Also, you can download and answer the 4 part test series that is already happened in our system. So you can check those question paper, you can answer them, you can verify whether you are correct or wrong. Okay, so that is also there. And what all you will get in this, you will get physics, chemistry, maths, biology, and CS, everything you will get in this. And you will also get question papers along with their typed solution, and we will come with a video solution as well. You can check the typed solution description if you are comfortable with text. If you are not comfortable with text, you can check the video solutions that we are going to provide. Also, we will be having live chat session where you can come and we can discuss whatever problems that you faced while answering the question paper, right? So everything will be there, and all inclusive price is $599. and if you use my good student, if you use my special code SAM100 under New Year promotion, you will get everything for only $499. right? This is a special promotion from my side. So if you add my promo code, you will get a special 100 rupees off in this package, right? And if you want Kannada, you have to pay something extra. You can get the Kannada language as well. You can check it out. The link of this is given in the description as well. You can check that out and choose based on your requirement, right? Now let's look into the what all are the derivations. So in the derivations, basically 5 mark long answer type questions that we are going to discuss in this lecture. There are small 2-3 marks derivations which are I consider it easy, and if you want you can check as I said chapter wise derivations. So total 5 questions will be asked as a long answer type questions. Out of that you have to answer 3. You can choose at least 2 derivations you have to answer. 1 questions will be there that you can answer without doing any mathematics. Okay, generally semiconductor chapter I always suggest semiconductor chapter half wave or full wave rectifier. That is very common. I have done that in our semiconductor chapter. You can go and check that out, right? So 3 questions that you have to answer, but out of the 3 questions, minimum 2 questions you will be derivation that you have to answer. You can answer all 3 derivations as well if you wish. There are enough derivations, and total marks, that maximum marks that you can score is 15. So if you watch this video, you will be good to go with all the 15 marks that you can answer. Now what all we are going to discuss, how many questions we are going to discuss? We are going to discuss only 12 important derivations. 12 very important derivations, so most expected derivations that we are going to discuss. Whatever is not discussed, they are not super important, but they are important. You can check the chapter wise discussions if you have any doubt, any questions. But after this, all the important derivations, these are all the important derivations, but I cannot claim that only from there it will come. But yes, if you go through this, you will be definitely be able to answer the 3 derivations required for your PU board. That much I can say. Right now you cannot do any suggestion from there. First question, derive an expression for the electric field at a point due to an infinitely long, thin, uniformly charged state wire using Gauss's law. So first, this is a 4 mark question. First question will be state and explain Gauss's law. So as I said, I am not going to discuss that. I am only going to discuss whatever is the derivation part in the question. So what you have to do, first you have to draw a diagram. Diagram is compulsory in this case. So assume that a straight wire of infinite length, say a wire carrying current, infinitely charged, not current carrying wire, sorry. So infinitely long charged wire, okay. So charge plus, you have to consider this is going to be infinitely long. So what we will do, just a second, we will draw a portion of it. Okay, that will be easier for us, and then we will say this is a infinitely long, right? So we'll just add some dot. So let's say AB is a infinitely charged wire. Okay, it carries some charge here, and we want to find, say, electric field at some point P. P is our point of inspection where we want to find a electric field. So what to do for this? First we have to consider an imaginary cylinder, this distance say R. Okay, you have to consider an imaginary cylinder of radius R and length say L. Okay, so that cylinder will become our Gaussian surface. This cylinder will become our starting point of Gaussian surface. Now you can do it. Okay, this is our Gaussian surface of radius R and length L. everything we have imagined. Okay, these are not given, only thing that is given is r. So at the end, whenever you are solving something, okay, you have to keep in mind whatever is given and whatever you are imagining. Whatever you are imagining, that you have to remove at the end. Whatever is given, that is at a distance from a charged particle. At a distance means this at a distance is given. Okay, so you have to find the electric field in terms of that distance, but this height is not given. It is an infinitely long wire, so this length is not given, so you have to remove this L at the end, right? So that is how we will solve. What else? Uniformly charged. So charge is given, uniformly charged it is given. So what is the meaning of uniformly charged? Uniformly charged means the charge density is constant. So linear charge density, since it's an infinitely charged wire, so we cannot consider total charge because that will be infinite. So what we have to consider is linear charge density. That's say lambda. Now what is the meaning of lambda? Lambda means if you take any unit length, that is 1 meter or 1 unit length, and whatever unit that we are using, and the charge in that unit will be lambda. So in 1 unit charge is lambda, in L unit, L is the length, so for 1 meter it is lambda, for L meter how much is the charge? So the total charge enclosed. Why it is important? Because Gauss's law based on the charge enclosed, right? So total charge enclosed Qn equals to lambda L. So charge of 1 meter is lambda, charge of L meter is lambda into L, right? Charge on 1 meter is say 2 coulomb, charge on 5 meter will be 2 into 5, 10 coulomb, right? So just you have to multiply with the length. So that is the first thing. Secondly, you have to mention that the electric field will be only in the radial direction. That means electric field, if you consider the electric field at P, that will be only in the radial direction. Why it is important to say? Because this is a Gaussian surface, right? So there will be one thing that you might say, okay, there will be an electric field in this direction also, in the direction of length, but actually in the direction of length there is no electric field because it is an infinitely wire. Okay, so they will cancel in this direction. Okay, only electric field that is possible here is along the radial direction. So that is very, very important. Only electric field will be along the radial direction. So electric field will only be along the radial direction, so that while doing the surface integration we can ignore these top and bottom surfaces. These two surfaces we will not consider because electric field is not present there, right? That's why it is important to mention. Now what is Gauss's law? According to Gauss's law, okay, now here this Gauss has two s's. Okay, so if you are adding apostrophe, you can skip this extra s or you can add it, both are fine. Okay, so if you remember Archimedes has s in the end, so Archimedes' law is Archimedes apostrophe. The extra s you can write, you cannot write, both are fine. According to English language it is okay. According to Gauss's law we can say that integration E dot ds equals to q enclosed by epsilon naught. Due to symmetry, E should be constant along the surface of the cylinder, right? See, the derivation is very simple and easy. Only thing is you have to write a little bit of stuff. So electric field will be constant on the surface of this cylinder. It's a three-dimensional object, right? So any point on the cylinder, because they are all equidistant, so whenever you are looking at any point, okay, everything looks same. So that is called symmetry. So whenever you are looking from, suppose you are looking standing at the position of the electric wire and you are looking at a cylinder, everywhere, even if you have rotated, they are exactly same. You will not be able to identify where you were at the beginning, right? So that is called symmetry. Because of the symmetry, electric field is constant. What is the meaning of constant? Constant means electric field magnitude wise it is a constant, so we can take it outside integration. Integration of a constant is, we generally take the integral out of the integration, right? Similarly, for example, a dx, a is a constant, so what do? We take the a out and we only integrate dx, right? Similarly here as well, E is a constant, so what we will do, we will take E out of the integration. Now here we have used vector form, but E is a magnitude, so magnitude of E should be constant, so that is that magnitude we are considering E. So E integral ds equals to Q enclosed by epsilon naught. Now what is ds? Very important. ds is, when you are considering Gauss's law, ds, close integral ds means total surface area. Close integral ds means total surface area. Close integration of dl, length, okay, in case of Ampere circuit law, close integral dl means total perimeter, okay, total perimeter for circle 2 pi r. Okay, for any other surface you have to add the perimeter. We will see in one of the derivations. So in this case, as you can see, total surface area of cylindrical part of the cylinder, right? So what is this area? So this area is 2 pi r l, right? You go back to your class 10th or class 9th where you have studied this. So surface area of a cylinder is 2 pi r l equals to Q enclosed. What is Q enclosed? Q enclosed you already know, lambda L divided by epsilon naught. Okay, now if you say, sir, 2 pi L is not the total surface area, you have to consider this surface and bottom surface as well. For them, I say that bottom surface and top surface we already excluded by saying that electric field is only along the curved surface, right? There is no electric field in the top and bottom surfaces. That's why we are not considering that. Those who are just typing that comment in the comment box perhaps. So now, so as you can see, there is a L, there is a L. So now L cancels. So whatever we have imagined, that imaginary term gets cancelled. So we have to find that 1 by 2 pi r times lambda by epsilon naught. Okay, let me rearrange it a little bit. So it will be 1 by, sorry, not 1 by, lambda by, it will be lambda by 2 pi epsilon naught r. Okay, so as you can see, it is inversely proportional to r only. It is independent, it is not dependent on r square. So that is something interesting. Okay, generally electric field comes out to be proportional to r square, but here as you can see, it is only proportional to r, right? 1 by r, sorry. Right, so this is the final derivation, this is the final answer. You can box it, you can square it, you can see. So this is the derivation, very very important derivation. Now next question, next derivation, let's see. Derive an expression for electric potential at any point in space due to a dipole. So this was while doing another series in decode NCERT, some students say, sir, please do this derivation. I feel this is important. They said, oh, it came in their question paper, college question paper. So I said, okay, this came once or twice, not super important, but since I have not covered it in our regular Brahmastra series, so I decided, okay, I will cover it in this lecture. Okay, so in this lecture I am going to cover it. So whoever asked it, please mention in the comment below that if you are watching this video at this point or not. So what we are going to discuss here, we have a dipole. What is the dipole? Obviously dipole has two charges, plus q and minus q. Okay, this is from the electric potential. This is not electric field. Electric field we have done. Okay, electric field axial position and perpendicular position both we have done. Okay, that is done in electric field chapter. This is from electric potential chapter. Okay, so in electric potential I feel electric potential is more important for your derivations rather than electric field. My expectation is from the chapter electric field there will be a numerical question, and from the electric potential there will be derivation. That is my expectation. It can be wrong, so you have to practice all the derivation from all the chapters, right? So they have given you 3 blueprints for 3 tests. As you know that there will be 3 definite tests. Okay, first you have to appear for board exam, then second you can appear for the first improvement test, then you can appear for the second improvement test. So there are 3 tests that you can appear, so that's why they have given 3 blueprints. So remember that. Now, so this is plus q, this is minus q, and you want to find a say electric potential at some point P. So how to do that? First we have to draw the dipole. We know that the distance from the midpoint, if I draw the midpoint, so this distance is A, this is also A. Okay, now what you have to do, we have to join these points. So it is not getting a straight line, so let me redraw it. Now when we have done it for our electric field, you remember that whenever we measure the distance is always measured from the center of the dipole, right? So this distance is r. Now what is the relationship with this r and these 2 points? That is very, very, very important. So what we will do, we will be doing in a way that it is, we can find it. First of all, you have to draw one perpendicular from this to this. Okay, this is a way of solving it. So if you draw a perpendicular from here to here, you can say let's not do this way, I will do it in a different way. So first of all, what we will do, we will draw we will extend this line, and from here we will draw a perpendicular. That will be easier. From here we will draw a perpendicular. Okay, and for this we will draw a perpendicular from here to here. Okay, say this angle is say theta, then this angle will also be theta. Okay, so this angle is theta, this angle will also be theta. Now what else? So first of all, you have to consider that this angle is very, 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 very small. Why so? Because the actual length of the dipole is very, very small. The distance between the dipole is very, very small. So this is A, this is also A. Now A is a very small number. That is the condition to be a dipole. That is the distance between the charges are very small. For example, if you consider HCl, okay, H and Cl, they are very close to each other. They are in a atomic bonding, molecular bonding, right? Not atomic bonding, molecular bonding. They have a bond formation, and the bond length is very small. Okay, in micrometer, in not even micrometer, it is in a picometer range. So the distance is very, very small. That's why you can consider this angle to be very, very small, because this distance is small. Okay, so first of all, what we have to do, we have to consider that this is A, and when you draw this perpendicular, this distance is equals to this distance. Okay, these 2 distances are equal. Okay, these 2 distances are equal. So from here to here and from here to here, these 2 distances are equal. Now you know that from this point to this point, say this point is say M, midpoint M. This is A, this is B. So PM is R. We already know that PM is equal to R, right? And this is say C, this is say D. So now what I am saying that PC equals to AP. So PC equals to AP. So what is the meaning of that? So AP is basically the distance, AP is basically PM plus MC. right? This, if you understand this geometry, this you just need to understand it. You don't need to prove it, you don't need to write it. Only thing, final result we will write directly. So you have to, but you have to understand why we are doing it. So this distance, if you can find, we can find the total distance, and if you can find this distance, you can find this distance, and we already know the formula for potential of a point charge, so you can apply that, right? So what is this distance now? So this angle is theta, this is A, so this is basically cos theta, A cos theta. So MC is nothing but A cos theta. If you understand this part, everything is very easy. So we can say that AP is basically R plus A cos theta. Okay, AP is equal to R plus A cos theta. Similarly, so this is their opposite angle. Similarly, what is the for this triangle, you can say that PD equals to PB, right? Similarly, PD is equal to PB. Now what is PB? PB is R minus A cos theta. So, or PB, or in, since we are writing AP, I will write BP as well. So BP is basically R minus A cos theta. This is the old trick that we have used, right? If one is plus, another one will be minus. So that trick that we have applied here, that's it. Now what all we have to do? So we have to consider the, don't worry about cos theta right now, we will see what we come to a final result, right? Now what is the potential, electric potential due to the positive charge? Electric potential due to a charge is KQ by R, right? That is the general formula. So in this case, K is K, Q is plus Q, so we are not using the sign, and R is R plus A cos theta for plus charge, right? So R plus A cos theta. And what is V minus? V minus is K minus Q by R minus A cos theta. So for electric field, we generally do not use the sign of the charge, we only find the direction. But in case of electric potential, because it's a scalar quantity, we have to use the sign as well. That is the difference between electric field and electric potential. So V plus V minus. The total potential is V plus minus V minus. That is the potential at the point P, right? So what we have to do? KQ by R plus A cos theta minus KQ by R minus A cos theta, right? Now you can take KQ common. Okay, KQ is common, and what is the LCM of these two terms? There is no direct LCM, so we simply have to adjust, and we have to use R plus A cos theta, R minus A cos theta, right? Now this will come here, R minus A cos theta minus, this will go this side, R minus A cos theta. Okay, so R cancels. Okay, so what we will get? KQ minus A cos theta divided by, this will be A plus B into A minus B, so R square minus A square cos square theta, right? So this is the final value of the potential. So you can erase this is just for your information. Now what we have to find? We have to do a approximation as usual. So what approximation we will do? We will approximate that A is very small compared to R. So basically what we are saying, this term is very small. So what we will do? We will do that Vp is equal to KQ minus A cos theta, there was a 2, I think, minus a cos theta, minus a cos theta, so there is a 2. Okay, let me take this minus sign here. Minus sign outside, so 2qa cos theta divided by r square. So we have ignored this term. This term is almost equals to 0, right? So now what is 2qa? 2qa is the dipole moment, right? This is the dipole moment. So it is minus k dipole moment p cos theta divided by r square. Right, so this is the final form. You don't need to worry about cos theta. Cos theta is a term because there is an angle, there should be some angle involved. Also, you can remove this cos theta by saying that this is nothing but Vp, since it's a scalar quantity, and K, P is a vector quantity, so P dot R divided by R cube. This is another way to write it. Okay, so r cube, only to add this r vector. If you do it in r cap form, then definitely you know only r square will be there. This is not required, but this is something extra, but here you have to, this is the final answer that is expected out of you. Now you should remember that there is a negative sign because we are finding the electric field near to the negative point. If you switch the positive and negative charge, then it will be positive. Because it is near to the negative charge, electric potential is negative in this case. The sign does not matter. Most important thing is it will be K also. One more thing, you have to put the final value of K at the end. What is the value of K? K is 1 by 4 pi epsilon naught. That value you have to put at the end. Okay, you cannot continue with K at the end till end. So last point you can put the value and mention in the bracket what is the value of K. So this is one derivation, and I don't like the way it was solved in the textbook. It is very complicated. Only thing that if you understand why this is a plus a cos theta, why this is minus a cos theta, then your life is very simple. Otherwise, if you follow the one it is given in your book, that is very complicated, and you will not be able to remember that derivation. Okay, if you follow this is a very simple, easy derivation. Okay, only thing that I guess, either you remember it or you understand it. Remembering, for some students remembering is easy, and understanding I have already explained. Now let's move on to the next derivation. It will be a very long video if I continue to explain everything in detail. So question number 3, derive the expression for the capacitance of a parallel plate capacitor. Very important, super important, another question from this chapter. So we have a parallel plate capacitor. One side is charged with positive, another side is charged with negative. Okay, so surface area, say A, both side has surface area A. This side has plus Q charge, this side has minus Q charge. Suppose the charge density is sigma, it will be plus sigma, it will be minus sigma. Okay, so what is sigma? Sigma is surface charge density, so it will be Q by A. Right, this is the definition of surface charge density. Now we know that for a single charged, infinitely long charge sheet, okay, the electric field at any point, okay, is given by sigma by 2 epsilon naught. It is independent of the distance. This is constant. Okay, so now there are 3 regions. Suppose this is region 1, this is region 2, and this is region 3. Okay, now what is the electric field due to this positive here? So in this case you will see that electric field will be positive will be in this direction, negative will be in this direction, and they are equal in magnitude, so they will cancel. Similarly in the region 2 will be also electric fields, they will cancel each other. So region 1 and region 2 electric field will be 0. You don't need to do this mathematically. If you can do it, very fine. Otherwise you have to at least show this in the diagram. This is very important. Okay, this is very, very important. You have to show this diagram. Either you do this in the diagram or the way it is done in your book, that is also fine. But that is not our objective. Our objective is to find the electric field inside the area. That's why you can skip this derivations, this proof that electric field is 0, but you have to mention that in the diagram so that the teacher understand, okay, you have understood the concept. Okay, electric field is 0. Now, in the region 3, where we actually want to find the electric field. So, in region 3, electric field is, what is the electric field? Due to positive, electric field will be away. Due to negative, it will be towards. So, both electric field will be in the same direction. So, they will add up. Okay, so electric field will add up. So, net electric field is equals to Q by 2 epsilon naught. This is the plus due to plus, and Q sigma by 2 epsilon naught. This is due to minus. Okay, so this is due to plus contribution due to the plus positively charged plate. This is due to negatively charged plate. So, what is the total electric field? Total electric field will be sigma by epsilon naught. Okay, so total electric field will be sigma by epsilon naught. Now, this is not it. We have to find the potential. So, what is potential? Potential and electric field is related by the factor E into D. V is equal to E into D. What is D? D is the distance between the plates here. Okay, this is the potential, formula for potential. So, let's put this value as well. So, now we will put all the values, right? Sigma is equal to Q by A. So, first of all, net is sigma by epsilon naught into D, or Q by A epsilon naught into D. This is the formula, final result. Now, we know that we have to find Q, because Q is equal to CV. That formula is in our back of our mind. So, A epsilon naught by D, that goes, everything goes to the other side and gets inverted. So, Q is equal to A epsilon naught by D. So, what is this? Q A epsilon naught by D. So, we know that from the known equation Q is equal to CV. Okay, we can write that C is nothing but A epsilon naught by D. Okay, so A epsilon naught by D, this is the expression for capacitance for a parallel plate capacitor. Now, this is when it is filled with air. Air has a dielectric constant 1, but if this medium is filled with a dielectric constant, say K, then this expression becomes C is equal to Ka epsilon naught by D. Okay, this is the when you fill it with a dielectric constant. Okay. Now, next derivation is derive an expression for the electric potential at a point due to a point source charge. So, this is also important from this chapter. So, what we are going to do, we have to find the electric potential at some point due to a source charge. So, we have a source charge, say Q, and we want to find the electric field at some point, P. Okay, so what we know that, suppose this distance is R. This is our known point, the distance should be known. So, what we know that at infinity, if you go to infinity, the potential will be 0. That is the definition, right? So, electric potential at infinity is 0. Now, if we take the charge at infinity and slowly do some work to bring it at P, that will be our total potential at point P, right? If we take a unit positive charge, bring it from infinity to this point, then we can calculate the potential at that point. That is the definition. Now, infinity is something is troublesome. Infinity we cannot go, right? Infinity is something which is beyond us. So, what we will do, we will assume that the charge we have somehow went to infinity, we take the charge and we have started our journey from infinity, and when we are coming towards our goal point P, we are somewhere in between. We already left infinity, but we are yet to reach P. So we are somewhere at some intermediate point, and we will say the distance of that point, say this point is A. Say this point is A. The distance of this point from our charge, we will say this is x. Okay, so this is our point, this is our starting point, this is how we will continue, right? Now, what is the force acting on this charge at when the charge is started at infinity, it reached at point A? What is the force acting on it? So force acting on the charge is equals to Q into E. Force acting on the charge, Q into EA. Okay, what is EA? So this is the charge Q. Now what is this charge? This charge, test charge, right? So test charge was +1. So we will put 1 here. What is the EA? EA is nothing but KQ by distance square, right? That is the formula for electric field. So electric field at this point A is KQ by x square, right? The distance is x in this case. So this is our force acting on this unit positive charge. Okay, KQ by x square. Now this is the force acting on this. So what amount of force we have to apply? So external force should be negative of this force, so that we can able to move it in the opposite direction, right? This is the force that is being repelled or being attracted. So when we apply the force, that applied force should be equal to exactly opposite to that of the force that is acting on it. That's why this is the negative sign. Now suppose applying this external force, we have taken it to a very small distance dx. Okay, we have moved it to a small distance dx. Now what is the work done? What is the definition of work done first of all, and what is the work done to move this test charge from A to a very small distance dx? So we know that work done is basically force into displacement, dot product of force and displacement, because it is moving in the same direction. Cos theta is 1, theta is 0, cos theta is 1, so it is just F into dx. So now it is small work done. Why it is small work done? Because the distance that we are moving is small. It's a differential, right? So this is a trick that we are going to use in physics. So that's why it is a small work done. dW is equal to F external into dx. Now what is the total work done? What is the total work done? Total work done definition, we know that total work done, the total work started where? It started at infinity, and where it will end? It will end at a distance r. So total work done basically is an integration. Our starting point is at infinity, our ending point is at r, and in between we have to do this small work that we have calculated. The entire thing should be in between. That is the trick, right? So infinity to r, what is F external? F external is minus KQ by x square into dx, right? Into dx, or negative sign will come out, KQ constant, it will come out. So only integration dx by x square infinity to r. Now what is the integration of dx by x square? Whoever answering in the comment, I will give you a heart. Okay, so minus KQ, integration of dx by x square is minus 1 by x. Ask Ankit sir why it is so, if you are not able to understand this. Okay, I am not going to tell you that, and I am going to tell you. So x square, dx by x square is what? Integral dx by x square. That means x to the power minus 2 dx, right? Integration. So we can say that x to the power minus 2 plus 1 divided by minus 2 plus 1, that is x to the power minus 1 by minus 1. So it will be minus 1 by x. Okay, plus constant we have not written because it's a definite integral, so constant will not come, right? So those who have forgotten the integration also, I have solved the integration, right? So now let's put the values. First of all, minus kq is our common thing. First we will put the upper limit, that is the condition, right? For first we will put the upper limit minus the lower limit. Now here already there is a minus, so minus minus plus 1 by lower limit, right? What is 1 by infinity? 1 by infinity is 0. 1 by 0 is infinity, so 1 by infinity is 0, right? So this will come out to be minus minus plus kq by r. So the work done to bring a charge from infinity, to bring a unit positive charge from infinity to a point P is kq by r. Now that is the definition of potential. So from the definition of potential, this is the work done, that is 1 by 4 pi epsilon naught q by r, right? So this is the final answer. Remember that work done is basically kq by r. You have to put the value of k at the last stage. Now next derivation. Arrive at the balance condition for Wheatstone bridge using Kirchhoff rules. Very important derivation. Okay. Even if you are not getting a question from this as a derivation, you will definitely expect a numerical. Okay, either numerical or a derivation is going to come from this. But in my opinion, last year 2024, they asked a numerical question from this. So there is a high probability that they might ask you the theory part this time. Okay, my drawing, pardon my drawing, I am not super good at drawing. Okay, but I can do whatever is useful, right? So this is the Wheatstone bridge. So this is P, this is Q, so this is R, this is S, and there is you have to complete the circuit. Right? Now what you have to draw? Suppose the current passing here is I1, current passing here is I2. Okay, then current passing through the galvanometer is Ig. Then what is the current? According to the Kirchhoff's junction rule, I1 is entering, Ig is leaving, total current should be equals to the addition of current. So the current that is exiting should be I1 minus Ig, right? So that if you add these two currents, you will get the incoming current, right? Similarly, I2 is coming here, Ig is also coming here, so the current that exits should be I2 plus Ig, right? This is the basic part that you have to do. Now you can use R1, R2, R3, R4 or PQRS, whatever you are comfortable with. Okay, now I have done already R1, R2, R3, R4 in one case, so now I am using PQRS, that I feel is very easy to remember. Now what we will do, we will take two loops. What are the two loops? First we will take this loop. Okay, this way, and this way. This will be our loop number 1. Okay, you have to name the loops, obviously A, B, C, D. Okay, first loop will be A, B, D, A. So loop A, B, D, A, and we will apply Kirchhoff's loop rule or Kirchhoff's voltage law, KVL. Okay, applying KVL, we get, first of all, how to apply KVL? Current into resistance. Here resistance itself is given by P. So I1 into P, current into resistance, I1 into P. Now first resistance is done, so we have to move along the path given here, A, B, then B, D. What is the resistance of galvanometer? Galvanometer resistance is generally denoted by the symbol G. So current through the galvanometer is Ig. Now are we moving in the direction of the current while moving from B to D? Yes, we are moving in the direction of current. So current into resistance. Next, what else? Now we have to complete the loop, that is D to A. So we started from A and we will end at A. That is how a loop is formed. Like, so we will end at A. So D to A, are we moving in the direction of current? Current is flowing in this direction, we are moving in the opposite direction. So as soon as we are moving in the opposite direction, a negative sign will be coming. And again current into resistance, I to Q. Now here we have no battery connected here, that's why we have chosen this loop. So no battery means equals to 0. If there was a battery, then based on the polarity of the battery, if the battery is also sending in the same direction as our chosen loop, then it would be plus battery voltage. If it is if the battery is sending opposite direction of our chosen direction, then it will be minus of the voltage. That's how we do the Kirchhoff's voltage law. Now we will take the second loop. Second loop again we are choosing without any battery. Now we will start from B, C, D, B. So loop 2 is B, C, D, B. Okay, so this is our second loop. Again KVL will apply. Now tell me, what is first? We starting point is B. Now are we moving in the direction of current? Yes, we are moving in the direction of current. So what is the current? Current is I1 minus Ig. First current into resistance. What is the resistance? Resistance is R in this case. Now next we ended up at C. Now we will move from C to D. Now are we moving in the direction of current? In this case, no, we are not moving in the direction of current, we are moving in the opposite direction of current. So it will be negative I2 plus Ig into S. Now again we have to complete the loop. D to B. D to B means again, are we moving in the direction of current? No, we are not moving in the direction of current. So another negative sign, Ig into G, and there is no battery connected, so it will be G. It will be equals to 0. Now what is the condition of balance of a galvanometer? Condition of balance condition of balance of a galvanometer is Ig equals to 0. Condition of balance is Ig equals to 0. So suppose this is equation number 1, this is equation number 2. So we have to put this condition in both the equations. From 1, what we get? So Ig becomes 0. So we get I1P minus I2Q equals to 0, or I1P equals to I2Q, or P by Q equals to I2 by I1. Right? Now from 2, again we will be putting Ig equals to 0. So first of all, in this equation, first Ig will become 0. So I1R minus this Ig will also become 0. I2S, this will also become 0. It equals to 0. Right? So, or I1R equals to I2S, or R by S equals to I2 by I1. Now if you see these two equations, okay, these two equations have same on the right hand side, okay, same expression for right hand side, I2 by I1, right? So their left hand side should also be equal, right? So therefore comparing, so say this is 3, this is 4, comparing 3 and 4, P by Q equals to R by S. This is the condition of balance for a Wheatstone bridge. Okay, P by Q equals to R by S. So to remember it, P by Q equals to R by S. Okay, top by bottom equals to top by bottom. Some people say P by R equals to Q by S. That is also fine. You can rearrange it in any of the two forms. I like to remember it P by Q is equal to R by S. Some tend to remember it P by R equals to Q by S. Both are fine. Does not matter. Let's move on to the next question. Derive an expression for effective EMF and effective internal resistance of two cells of different EMFs and internal resistances connected in series. So I have done the parallel combination in our lecture, but when I was going through the previous year questions, I saw this question also has come quite a few number of times. So I decided, okay, let me cover this in this portion. So this one I have not done in our regular class, so in the regular Brahmastra series, so I will be doing it here. Okay, see parallel one, if you want to check, you can check my current electricity PU to Brahmastra. Okay, now this is supposed to cells of epsilon 1, epsilon 2. If the question is easy, then this one will come. Chance, I'm saying. If the question is slightly difficult, then the parallel one will come. Okay, so now they are connected to some external resistance, say R. The current in the circuit, say I. Okay, now what is the equivalent? The equivalent will have only one cell, and only one internal resistance connected to the same external resistance R, and the current in the circuit will be same. That is what is called equivalent circuit. Equivalent circuit means this combination can be replaced by one single element that will have the same condition. Other conditions will remain unchanged. That means the external circuit will be remaining same, the current in the circuit will remaining same. So this is what we are trying to find. We are trying to find this EF equivalent and R equivalent. Okay, first of all, let's see what is Kirchhoff's law is saying about this circuit. So Kirchhoff's law is saying that if you can consider this is to be a closed loop. So closed loop means, first of all, we will start here, say point number 1, 2, 3, 4. So we will go through this loop, right? So first we will consider 1 to 2, no resistance, 2 to 3, only one resistance R, current in the circuit through all the component is same, right? Through all the component is same, no parallel combination, everything is connected in series. So in series connection, current is same. So I current is passing through this resistance. So first, are we going in the direction of current? Yes, we are going in the direction of current. So IR. What else? Now we have reached point 3. Now 3 to 4, again no resistance. Now 4 to 1, we have two resistances, right? First, consider first resistance, R2. So are we going in the direction of current? Yes, we are going in the direction of current. So plus IR1. Next, we will ignore these batteries. As I said, we will ignore these batteries. We will consider the other resistance. Resistance is R1. Current is I. Are we going in the direction of current while traveling from 4 to 1? Yes, we are going in the direction of current. So IR2. Dash should be equals to, now we have to consider the batteries. Now both batteries are connected in series. What is the direction of current that is originally sent by this battery? So this battery would have liked to send a current in this direction. This is positive, this is negative, right? So this battery would have sent a current in this direction. What about this battery? This battery should also have sent the same direction, right? So both of the batteries are sending the current in the same direction, so they will be simply epsilon 1 plus epsilon 2. If one of them was sending connected in the opposite polarity, then that would have been negative sign. But for our simplicity, we have considering both of them are sending in the same direction, so that's why epsilon 1 plus epsilon 2. Or we can write IR equals to epsilon 1 plus epsilon 2 minus I common R1 plus R2. This is the external voltage. This is the terminal voltage. Sometimes this is also called terminal voltage. So terminal voltage is epsilon 1 plus epsilon 2 minus I R1 plus R2. This is for the combination. Now what about the equivalent circuit? For the equivalent, both diagrams are important, okay? For equivalent circuit, okay, this is the short form of circuit, CKT. So we can say that IR, now in this case again we can apply the KVL, I into R. Now first this resistance, there is no resistance here, IR in the same direction. Now REQ into I, this is also same direction, right? So now by now I hope you have understood what we are doing, equals to epsilon equivalent, right? So here also everything is in the same direction, current is also being sent in the same direction. So by Kirchhoff's current law, this is the Kirchhoff's voltage law, this should be the answer. So IR equals to E equivalent minus IR EQ. Now this is the terminal voltage, so V equals to E EQ minus IR EQ. Now this is equation 1, this is equation 2. Now comparing 1 and 2, what we can say is that, so this must be equals to is this, right? This has, both of them are no I is involved in this. So comparing this, we can say 1 and 2, epsilon equivalent is equal to epsilon 1 plus epsilon 2, right? Now, and what else we can say? So this is, these two terms have current I, so whatever the constant should be equal, so R equivalent should be equals to R1 plus R2. Simple derivation. Okay, if you do that, there will be some extra question. Other than that, this will generally come as a 3 marks or 4 marks question. Okay, there will be some other part to that question. Okay, but this is very, very simple, easy derivation, right? If you get this derivation, you can answer it, right? Let's move on. Question number 7. Derive the expression for the magnetic field at the point on the axis of a circular current loop. So what we will be doing, we will find the magnetic field. This derivation I have done in the regular class, but this is a very, very, very important derivation. Almost once every alternate year this question comes, right? That's why I am doing it. Okay. So what we have to do, this is a current carrying loop, okay, carrying some current, say I, and we want to find the magnetic field at some point, say P. So what we have to do, we have to consider a small element dl. I hope you remember it. We have done it multiple times, this derivation. Okay, the radius of the loop is R, and the distance from the center is x. So the radius of the loop is R and the distance is x. This is a small element dl. The direction of dl and the current is 90 degrees, theta equals to 90 degrees. This angle, say phi. Magnetic field at this point will make an angle phi with this. These are the things that you have to remember. Now, what else? Sorry, not this angle is phi, sorry. This angle will be phi. Okay. Now, also, you can consider an radially opposite point where the same dl you can consider, and for the same dl you will find another magnetic field, okay, which will have the same thing, everything will be same. This angle will also be same, okay, phi. Now for this, what will happen is that if you divide it into components, okay, if you divide it into components, okay, these two components will be equal and opposite and they will cancel. Okay, so sin phi components will be cancelled, so only component that will be left is along the x-axis, right? So x component is important. What is the x component? So this is b cos phi, which is very, very important. In fact, we will write db cos phi. Why db? Because we are doing it for a small element dl, right? Now, so these are the first part that you have to draw. This diagram is very, very super important. The bottom part you can draw using dotted lines, okay, and try to match them. Don't draw it like me casually, okay? You have to draw it properly so that you get full marks. So diagram is very, very important and you get 1 mark for drawing it. Now what else? First of all, from what law we have to use? We have to use our old friend Biot-Savart law, right? So what is Biot-Savart's law? According to Biot-Savart's law, we know that the small magnetic field dB due to a current carrying element dl is given by mu naught by 4 pi. Okay, this is our, as I say, as you go to temple or any place, you have to wear something, right? Tika. Okay, if you are Muslim and you are going to masjid, you have to wear the cap. Same thing, if you are going to a temple, after visiting the temple, the priest will give you a tika in your forehead. So this the same thing, right? If you are Christian, you are wearing a cross. So every religion has something. So in physics we also have this tika. This is our physics religion, right? Now mu naught by 4 pi. Now what is I dl sine theta? Now as I said, sine theta in this case, so if you consider this point, at this point, okay, this is the tangential direction, right? DL is along this direction and R is in this direction. So both should be tangent, but according in a different plane. Both tangents should always be perpendicular to each other. Any tangent to a curve, okay, any tangent at the same point are drawn on a curve, 3-dimensional plane, they will always be 90 degrees. That is the main thing. That's why the theta is 90 degrees. If you are confused why they are 90 degrees, right? Now, so this is the ideal sine theta. Sine theta is 1, so we are not considering that. And this is x, this is r, this distance is r. We are trying to find the magnetic field due to this, right? So here it will be r square. Now you can apply Pythagoras theorem to find this value of r. What is r? R square equals to r square plus x square, right? This is Pythagoras theorem. So next line we will put this value as well. So mu naught by 4 pi I dl r square plus x square. This is the total magnetic field. But total magnetic field, calculating the total magnetic field useless, because the final magnetic field is only along x direction. Final magnetic field is only along x direction. Y direction magnetic field, they will automatically cancelled. For each and every point there will be a diametric opposite point and y components will always get cancelled, and only the field that will remain is along the x direction. So dbx, we are interested in only dbx. So dbx is basically db cos phi. Now what is db? db we have already calculated, mu naught by 4 pi I dl by r square plus x square. Now look into this triangle and tell me what is the value of cos phi. From this triangle, what is the value of cos phi? So cos phi is, some people have curly brown hair. Curly means cos, brown means base, hair means hypotenuse. So cos theta is base by hypotenuse. Okay, so base by hypotenuse. For this angle, if this is the angle, then this is the base, this side is base, right? So this side is base, means base is r. And what is hypotenuse? Hypotenuse is this is our 90-degree angle, so this is the hypotenuse, so that is r. Now r we have already calculated, so we can say that r by r square plus x square square root, or square root can also be written as a to the power half, right? So we will use this here, right? We will use this formula here, or mu naught by 4 pi I dl here. Oh sorry, this is already written, right? My mistake. We only want to put the value of cos theta here, right? So cos theta is r divided by r square plus x square to the power 2. So let me simplify this. Mu naught by 4 pi, it is as well there, IR, okay, this IR is not voltage, okay, don't get confused. This I is current, this R is length, R square plus X square into DL, right? So this is the dBx, small component due to this small portion. Now what will be the total magnetic field? Total magnetic field will definitely be integration of dBx. So as you can see, this part will be constant. They have no variable involved here. Here x is a fixed given distance. Here x is a fixed given distance. It is not changing. Only thing that is changing is this dl portion. So this dl portion is changing, right? So when we are doing integration, so this mu naught by 4 pi IR by r square plus x square, this is constant, so only dl will be here, right? Now what is this integration of dl? So if you remember few derivations back when I was discussing Gauss's law, I said closed integral of surface means total surface area. Here you can say that it will be a closed integration of the linear closed integration. Linear closed integration means total perimeter. So what is the perimeter of a circle? Perimeter of a circle is 2 pi r, right? So integration dl is basically 2 pi r. 2 pi r. Remember that here r is the radius of the circle, right? So now let's simplify. 2 pi cancel 4 pi, so it will become mu naught by 2. Now it is no longer the same formula from where we have started. Mu naught by 2, this r multiplies, so I r square divided by r square plus x square to the power 3 by 2. This is our final Bx. So this is the magnetic field at a distance x from the center. Now what about at the center? So they might ask what will be the electromagnetic field at the center. So magnetic field at the center basically means where x is 0. So if you put this x equals to 0, then you will get the magnetic field at the center. That means B center will be mu naught by 2. You just have to put x equals to 0 here. I r square divided by r square to the power 3 by 2. So r square to the power 3 by 2 means this 2 cancel, so it will be r cube, right? So it will be r cube. Right? Now r square by r cube, that is, it will cancel, only one r will be left. So mu naught by 2 I by r. So at the center of the coil it is a constant value, right? I by r. This is the extra information that you should know. Next, derive an expression for force per unit length on two infinitely long parallel straight conductors carrying current and hence define ampere. So first let us draw two parallel current carrying wires. Okay, so this is say AB, this is CD, two parallel wires carrying some current. This one is carrying say current I1, this one is carrying say I2. Okay, the distance between them is say D. Okay, now we have to find the force per unit length due to one on another. right? So first we have to consider a given length, say L. This is very, very important. The length is not given. Force per unit length you have to calculate. That means we have to divide, final result has to be divided by this value L. This is very, very important. So this is L. Just consider this portion L. Now this wire is carrying a current I1. What will be the magnetic field due to this current carrying wire at the location of the second wire? So magnetic field due to the first wire at the location of second wire, how can we calculate it? You can remember that this is nothing but you can consider this to be a circle of, right? This is a circle of radius, this d, so it will be mu naught I1 divided by perimeter of this circle, that is 2 pi d. Okay, this is the magnetic field due to first wire at the location of the second wire. Now why we are calculating the magnetic field? Because we know that force on the wire 2 due to wire 1 can be given by B I L. Now remember here B is due to first wire, I is due to the second wire, length we have assumed length L. So this is the force on the second wire due to the first wire. This is the formula. Now let's put the value of B1. So mu naught by I1 by 2 pi d I2 L. So what is that force? Mu naught I1 I2 by 2 pi d into L. Now what will be the force on the first wire due to second wire? Force on the first wire due to second wire will be B2 I1 L. Bill, right? Now what is B2? From here similarly you can say B2 will be mu naught I2 by 2 pi d. Same formula in this side, right? Now put the values. Mu naught, this is one of the very, very easiest derivation, but it is also very, very common, right? So from here you get mu naught I1 I2 by 2 pi d L. Now what you can see from these two derivations, you can say that, so F21 magnitude wise F21 should be equals to F12, right? Magnitude wise F21 should be equals to F12, and say this force is equals to F, say, right? Both of them are same, right? So this F equals to mu naught I1 I2 by 2 pi d into L, right? This is the common force. Now force per unit length, small f, is defined by this common force divided by L, force per unit length, that is mu naught I1 I2 by 2 pi d. Now this is not end. You have to define ampere from this derivation as well. So what to do for that? So we have to assume that I1 equals to I2 equals to say 1 ampere, okay, D equals to 1 meter. Then what is this force? Then this force will become mu naught by 2 pi. Now what is mu naught? Mu naught is 4 pi times 10 to the power of minus 7 by 2 pi. So it cancels. So you get 2. So you get 2 into 10 to the power of minus 7. After this, you have to write it in words. What is that? Ampere is the current when flows through each of the two parallel conductors kept at a distance of 1 meter experiences 2 times 10 to the power of minus 7 Newton per meter force. Newton per meter means force per unit length is 2 into 10 to the power of minus 7 Newton per meter. Right? This is the definition. You have to write this with word to get the full marks. Now next question, deduce the relationship between N, U, V and R for refraction at a spherical surface where symbols have their usual meaning. Symbols have their usual meaning, not symbols. right? Now remember, this is very important. The diagram is very important. So you have to draw a curvature like this. Okay, suppose this is the center of curvature. Now exactly whatever I am doing, you have to do that same way. So suppose this is an object, say O, light is falling, this is the mirror, okay, and this is the incident light, this is the reflected light, right? Now if you join the center of curvature to this point, what we know, this will be a normal at this point, right? That is why it is called center of curvature. So normal at this point means this angle will be angle of incidence and this angle will be angle of refraction. Very important to remember. Exactly the same way you have to draw the diagram. You cannot take the object here, then it will create some confusion. You will face difficulty. Now what you have to do, you have to mark this angle, say alpha, this angle beta, and this angle gamma. Very important. Okay, this is how you will do. Also you will imagine that this curved line, okay, so this is say a point, this is our image I, this is say point P, and this is say mirror M. Okay, now what you have to imagine in your head, even though this is a curved line, actually it is a straight line. Okay, why so? So basically this point and this point are same. Why so? Because this ray is very close to the center of the mirror, center of the slab. They are called paraxial rays. Very important, and all the formulas, all the geometries that we use are valid for paraxial rays only. Okay, so this is a paraxial ray case where everything is paraxial. That's why this point and this point are very close, so we cannot distinguish between them. The first medium say N1, the second medium is N2. What we are trying to find? We are trying to find the relationship between this object distance, which is generally minus u, right? Object distance is always negative. What else? We are trying to find the radius of curvature r and the final image distance v. So this is what we are trying to find, the relationship between these quantities and N1, N2. Okay, so first we have to consider triangles. We will consider this triangle first. Okay, this triangle first, right? So if you consider this triangle OPC, triangle OPC, names are not super important, you have to name it. Okay, from this triangle, if you see, this is a triangle, right? OPC. So this is our angle alpha, this angle is gamma, and this angle is I, right? Now we know that sum of two internal angles is equals to opposite external angle. For a triangle, sum of two internal angles equals to the third opposite external angle, right? So from here we can say that alpha plus gamma equals to I, or we can say that I equals to alpha plus gamma, right? So this is the first thing that we have noticed. Next we have to take this triangle. Okay, what is this triangle? CIP. From the triangle CIP we can write, what we can write? Now in this case you can see that these two are internal angles, r and beta, whereas gamma is the external angle, opposite, third opposite external angle. So r plus beta equals to gamma, right? R plus beta equals to gamma, or r equals to gamma minus beta. Okay, now if you don't want to use alpha, beta, gamma, you can use any other symbols. Very good, no problem in that. So this is the main thing that we have found. In your textbook they have used angle ABC, angle OPN, angle PQR, which is very difficult and very bothersome. Okay, that's why I am using symbols which is very easy to remember. Now, so this is the main thing, right? Now What else? Let's see what is the value of these angles. So first we will find tan alpha. Tan alpha is perpendicular by base. So perpendicular in this case is, this is the perpendicular. Now what I said, you imagine this point and this point are same, right? So perpendicular is basically this distance. So PM, perpendicular is PM divided by base. Base is OM, right? Tan alpha. Now alpha is a very small angle because the point is very close to the center of the glass, the center of the surface. So alpha can be approximated as PM by OM. Why? Because for a small angle we can approximate sin theta nearly equals to theta, also tan theta nearly equals to theta. These two can be approximated to be theta, and cos theta nearly 1, right, for very small value of theta. So we have added that approximation here. What else? Now find tan. Similarly, we can find tan beta equals to, tan beta means this angle. Again we will consider this triangle, bigger triangle. So this will be PM by base IM, or beta equals to PM by IM, right? Now again tan gamma, everything has to be calculated. Gamma, tan gamma is this triangle, this triangle. So for here again PM, perpendicular is always PM, base is in this case is CM, base is CM, or we can say gamma equals to PM Prime Minister by Chief Minister, right? So now this part is done. This is the background we have to do when you are drawing this diagram. As soon as you draw the diagram, you can do this mathematics. Now I and R we have calculated. Now what next? We have to apply our known old friend Snell's law. Okay, we have to apply Snell's law. What is Snell's law? Snell's law says that N1 I1 N1 I equals to N2 R. Right, that is the Snell's law. Now sorry, not this one, my mistake. N1 sin I equals to N2 sin R. Now again we will do the same approximation because it is very close to the center. Sin I is very small angle, so if I is small, definitely R will also be small. So approximately we can say that N1 I equals to N2 R, right? Or N1, what is I? I is alpha plus gamma equals to N2 R. What is R? R is gamma minus beta, right? Now put the values of alpha, beta, gamma from the calculations that we have made. N1 alpha is PM by ON, PM by ON, plus gamma. What is gamma? Gamma is PM by CM, N2. What is gamma? PM by CM. What is beta? Beta is PM by IM. Now if you see, all the terms have PM in the numerator, so we can simply cancel all the PMs. So I am a lazy person, so I am doing it like this. You have to write it one more line here, okay, right? So everything is now this. Now what is ON? ON, I think I made some mistake. It will be OM. There is no N here, right? ON. Now what is ohm? OM. OM is minus U. So you have to put with sign plus CM. What is CM? CM is R. Now if you are confused about sign convention, remember that everything on left hand side is negative, everything on the right hand side is positive, right? Along positive x-axis, along negative x-axis, right? If you remember the axis, you will be clear. Now what else? CM, again CM is 1 by R minus IM. What is IM? IM is V plus V, right? So this is the final form. Now you have to rearrange them one by one. So what I will do, I will erase this part. So what we will get? N1 by minus U plus N1 by R equals to N2 by R minus N2 by V. Now we will take this minus N2 by V on this side, so it will become N2 by V minus N1 by U equals to N2 by R minus N1 by R. Okay, or we can say N2 by V minus N1 by U equals to N2 minus N1 by R. This is the final relations that we are looking for, right? Now this derivation is important, this formula is also important, because the next derivation that we are going to do is based on this formula itself, that is Lensmaker formula. So deduce the Lensmaker's formula. So what is that? First of all, you have to draw the diagram. Okay, suppose there is a, again for lens also the same paraxial concept will go on. Okay, so this is say object distance minus U, this is the image distance V, the radius of curvature of the first surface, say this is C1, the first surface is R1, for the second surface it will be on this side, it will be R2. Okay, now first we will assume that this is the surface, only first surface is there and the ray is passing with minus U and the image is forming somewhere in between, and we will say this is V dash. Why so? Because we know that this is say N1, this will also be N1, the intermediate will be N2. So we know that N2 by V, in this case V dash minus N1 by U equals to N2 minus N1 by R1, right? This is the R1, this is the first surface. Now when the same thing comes for the second surface, okay, so now the radius of curvature is on this side, so it will be minus R2, and our immediate object distance will be plus V dash, and final object distance, final image distance will also be, final image distance will be V, right? So in this case what we have done, I think sign is not important here because sign is already included in this formula, so we are not using the sign in this case. Okay, so if you are using sign, you have to use sign in all the formulas. So N2, only thing that you have to be careful at, what is your thing that you are looking for. Now final image distance is V and its corresponding refractive index is N1. So N1 by V minus N2 by V dash equals to N1 minus N2 by R2. Why so? Because now light is traveling, first medium is N2, final medium is N1, So n1 minus n2, final minus initial, right? So this is how it is going to be. Now add them, simply add them. Okay, if you want a little bit more detailed derivation, you can check our Brahmastra series. You can just simply add them. There I have done it slightly more detail. So this one will cancel. So n1 by v minus n1 by u equals to, now if you take the only n2 minus n1, then you will get 1 by r1. This is positive, but it will become automatically negative. So that's why we are not using any sign here. The sign automatically comes here, right? Now this is n1 common, should be common from both sides. So 1 by v minus 1 by u equals to n2 by n1 minus 1 by r1 minus 1 by r2. Right? Now the definition of focal length f says that if the object is kept at infinity, then wherever the image forms, that is the focal length, right? So from the definition of focal length, if u is infinity, then v should be focal length. So 1 by f minus 1 by infinity, 1 by infinity will be 0. So definitely 1 by f will be, what is this? This is nothing but n21 minus 1 by r1 minus 1 by r2. This is the general form of Lensmaker equation, but in general n21 is the refractive index with respect to air. Okay, because most of the lenses are placed such that here also air, here also air, so air has one refractive index. So whatever is the actual refractive index of the medium or absolute refractive index of the medium, that is replaced here. But this is the general form of Lensmaker's formula. Okay, with slight description of the image and the formula, you will get full marks. Okay. We are already running too long, that's why I am trying to finish it little bit quicker. Next question. Derive the expression for refractive index of the material of the prism in terms of angle of minimum deviation and angle of the prism. So this is the diagram you have to draw. This is the diagram you have to draw. Then you have to use this formula that minimum deviation is given by when I1 is equals to I2, or this formula here it is written in the graph itself, so that is why you can use that. And every detail you have to do, whatever detail is given here, the exact detail you have to do, and then from there you have to do this derivation that n21 is equal to sin I by sin r from Snell's law, obviously, or A we have already calculated. I is basically A plus delta m by 2, and from here we have calculated R is equals to A by 2. Okay, from there, here you can say R equals to A by 2, right? So you just need to use this over here, and this is the final relationship. Simple derivation, but very important, often it comes. Now last derivation, using Huygens principle, arrive at the Snell's law of refraction of a plane wave. Very important derivation. So we have a separation of two medium, a light ray is coming, okay, the same time another light ray is also coming, okay, it falls here. Now if you draw a perpendicular from this to this, okay, this is a perpendicular, then this is the incident wavefront. Okay, this is how the wavefronts are defined. Okay, all the wavefronts should be parallel, means that here the wavefronts are parallel, so that means they will have perpendicular distance, means that will be the wavefront. Now this should be the angle of incidence. You can find the angle of incidence in using the additional way as well. This is the angle of incidence. Now after falling on this medium, it will bend. Now by the time the ray reaches from here to here, suppose this is incident wavefront AB, by the time the light reaches from B to C, the light which was at A already entered the second medium and reached another point, say D. Okay, so this is the final point. So this will be the refracted wavefront. Now definition of refracted wavefront, this should be also 90 degrees. This angle should also be 90 degrees, and this will be our angle of refraction R. Okay, so these are the main things that you have to remember. Now speed of light, say in this medium, say v1, speed of light in the second medium, say v2. the time is same, so whatever time taken by the light to reach from B to C, the same time is taken by the light to reach from A to D, so that is also T, right? Now what is the distance BC? Distance BC is V1T, right? The speed of light into time. What is the distance AD? Distance AD is V2 into T, same time. Okay, time is taken by both the light to reach at their respective position is same, right? Now according to Snell's law, what is Snell's law? Snell's law, we know in our back of our mind, Snell's law talks about sine theta, sine I and sine R, right? So what we will be doing, we will first use this triangle and knowledge of the fact that this is a right angle triangle, we will find the sine I. So sine I, what is sine I? Sine I is some people have perpendicular by hypotenuse. Some people have. So perpendicular means this is the angle. For this perpendicular is this BC. And what is hypotenuse? Hypotenuse is opposite side. So this is hypotenuse AC. Now what is BC? BC is V1T. So V1T by AC. Similarly, we will also calculate sine R. What is sine R? Now consider this triangle, right? This is the perpendicular. Sine R means this. So again, perpendicular, for this perpendicular is AD and hypotenuse AC. What is AD? AD is V2T by AC. Now we know that from the knowledge that what we have to do, we have to find sine I by sine R. That is one good thing that we know. Okay, if we are starting without having any knowledge about Snell's law, then it would have been completely different, right? But we know that. So V1T by AC divided by V2T by AC. So this AC cancels, both are division, this T cancels. So we get V1 by V2, right? Or we can write this as C by V2 divided by C by V1. Can I do that? You have to check it mathematically if it is correct. So what we have done, we have we have multiplied C here, then so what we have done, V1 by V2, right? So we have multiplied C on the both sides, and then we have taken this as a term C by V2, and then we have taken this on the below, so it will become C by V1, so that it goes up, right? Whatever is the extreme below, that goes up generally, not generally, always. So we have used some clever mathematical tricks. Now what is C by V2? C is the speed of light in vacuum, V2 is the speed of light in the medium, that is, this is the absolute refractive index of the second medium. Similarly, C by V1 is the absolute refractive index of the first medium. Now do the cross multiplication. So N1 sine I is equal to N2 sine R. That is our Snell's law. This is our Snell's law from here. So description, everything we have to give. You have to give what is the incident wavefront, what is the refracted wavefront. So everything you can check again. As I said, wave optics chapter already discussed in Brahmastra series. There you can check. But this is a very important derivation. So that's why I just came here to practice this a little bit more, right? So I will be back with new numerical questions on Friday. Till then, bye. I'll please don't forget to like, share and subscribe it with your friends.